How to obtain P using the maximum likelihood estimator for the geometric distribution. We should recall that the solution to the likelihood function is the differential law. Is the differential law of the likelihood function equal to 0. But in this case, this function, we are not using theta, we are using P, because we are asked to estimate P. So we'll be differentiating with respect to P. We recall from probability that probability of success plus failure is equal to 1, which implies that P is equal to 1 minus Q. Also, Q is equal to 1 minus P. So we can write this as f of x to be equal to P 1 minus P x minus 1 to make it uniform. We also note that the likelihood function for P is equal to the products of that function. So this is the function. All we need to do is to substitute the function into the likelihood function. So we have, instead of this, we put this, which is P 1 minus P raised to the power of x minus 1. So this is now the likelihood function of T. All we need to do, if you take the product of this, it will give us at last P raised to the power of n, because if you sum a constant, you get n. Multiply by 1 minus P. If you sum this, you get summation of xi minus this is a constant n. So this is what we have. Very simple. If this is our likelihood function, all we need to do is to take the log. How do we take the log? We take the log of this function. So the log of this is equal to, we are taking the log, n will come down. So it will be n log P and plus summation of xi minus n log 1 minus P. So that is what we have. We also said that for we to get the solution for the maximum likelihood estimator, we will take the differential of this log function. So if we differentiate this with respect to P, we get this, differentiate this, we get n over P plus summation of xi minus n all over 1 minus P. Since we are differentiating with respect to P, we have this to the minus 1. So to differentiate this, we get 0 minus 1. So it implies that we have n all over P, this concept, minus summation of xi minus n all over 1 minus P. Like we said, once we take the differential, we equate it to 0. So we equate the whole of this to 0, which is n all over p minus summation of xi minus n1 minus p is equal to 0. So for mathematics, if we take the LCM, we have p1 minus p all over n multiplied 1 minus p minus p summation of xi minus n is equal to 0. Of course, this will go and we have n minus np minus p summation of xi minus, okay, minus p and this give us plus np is equal to 0. So if you watch, this can cancel this because minus 1 plus 1 is equal to 0. So you'll be left with this and this. Let's move it all this way. So it means we have just n minus p summation xi, I ranging from 1 to n, is equal to 0. Meaning n is equal to, this is going over here, to p summation xi, I ranging from 1 to n. So for we to get p, we divide both sides by summation of x. So we divide both sides by summation of xi. If we divide both sides by summation of xi, we get n all over summation of xi is equal to p summation xi all over summation of xi. So this will cancel this, and now be left with p will be n all over summation of xi. If you watch out, you see that this is the opposite of me. So you have it as 1 all over x divided. So it means the maximum likelihood estimate of p is this. The estimate, since there is a cap here, it has come to an estimator. It's equal to 1 all over x divided. Meaning the likelihood estimate for the geometric distribution is biased. Yes, it's biased because it did not follow the normal pattern.